Section 12.2. Our objective today is I can find lateral areas, total areas, and volumes of regular pyramids. So first of all, a pyramid has only one base. So as you can see in my diagram here, notice that there's one base. Notice that there is a vertex point that in this case the base is a rectangle, and notice that the lateral faces are not perpendicular or vertical, they're slanted, and the lateral faces are all triangles. So triangles form the sides of the pyramid. The lateral edge is the edges or corners where the triangles meet. So this would be a lateral edge. Okay. The altitude is a segment from the vertex and perpendicular to the plane of the base, and so that would be this red segment right here. Okay. The height is the length of the altitude, and in a pyramid there's actually two different heights. There's the height of the pyramid, which is the altitude, and then there's what we call the slant height, which in my picture would be the segment VE, which is an altitude of one or an altitude of the lateral faces that form the triangle. So the slant height and the altitude are two different lengths, and the symbol we use for slant height is a cursive L. Okay, that's the symbol for slant height. Okay, then we want to talk about regular pyramid. Okay, a regular pyramid is one whose base is a regular polygon. Remember, regular polygon, all sides are congruent and all angles are the same length. Okay. In a regular pyramid, all lateral faces are isosceles triangles. Okay. And the slant height is the altitude of one of these triangles. Okay. Number 4. The fourth property is all lateral edges are congruent. And number 5. The altitude of the pyramid meets the base at the center of the base polygon. Okay. And so we have several different theorems that give us the lateral area and the total area. The first one, theorem 1. Okay. The lateral area of a regular pyramid, and notice it must be a regular pyramid, equals half the perimeter of the base. Oops. Times the slant height. So as a formula, LA, lateral area, is equal to 1/2 the perimeter times the slant height. And again, remember that we are looking at the triangles. So the 1/2 comes from the fact that we want to find the area of each one of those triangles, and the area of a triangle is 1/2 base times the height. So the 1/2 comes from area of the triangle. The perimeter represents the base, but it's the bases of all the triangles that form the sides. And the height is the height of each triangle, or the slant height. Okay? So it's really just putting those all together. Then the second theorem is for total area. So the total area of a pyramid is its lateral area plus the area of its base. Okay, so as a formula, total area equals lateral area plus capital B. Remember, the capital B means base area. Okay, and our last theorem is for volume. The volume of a pyramid equals 1/3 the base. I'm sorry, 1/3 the area of the base. Times the height of the pyramid. And this is the height, meaning the altitude, not the slant height. Okay, so as a formula, volume is equal to 1/3 base area times the height. Okay. So let's look at an example. Made that a little bit too exaggerated there. Try again. Okay, so this base is supposed to be a square, even though it doesn't look like it. And the altitude, is 12, and the slant height is 13. Okay, so this is a regular square pyramid with its height of 12 and a slant height of 13. Find the length of the base edges and find the lateral area. So we know if we take this triangle and connect, the 12 and connect it to the 13, we actually have this right triangle where this is 12 and this is 13. Okay, so it's kind of like you're slicing through. And now, because it's a right triangle, we can find this length, which is going to be half of this length right here. Okay, so we're going to do 12 squared plus x squared equals 13 squared. So we get 144 plus x squared equals 169. Subtract 144, we get x squared equals 25, so x equals 5. So that means half of this is 5. So each side then is 10. So then we know that that the base edges are each 10. Okay, and then we will need to find the length of a lateral edge. Okay, so taking one of the face triangles, which is this, we know this is 10. We know that this altitude is 13. It's the slant height of the pyramid, but it's the height of the face triangle. And we know that these are isosceles, and so therefore we can find the length of a lateral edge by, again, using Pythagorean theorem. So x squared is going to have to equal 5 squared plus 13 squared, which is 25 plus 169, which is x squared equals 194, and take the square root, x equals the square root of 194. So each one of these lateral edges is the square root of 194. Okay, so now let's find the lateral area of the pyramid. Well, remember, the lateral area has to do with the area of all the triangles that make up the pyramid. And remember, the formula is 1/2 the perimeter times the, whoops, I wrote H, it should be L, times the slant height. Okay, so it's 1/2, and it's 10 times 4 for the perimeter, times the slant height, which is 13. So 2 goes into 10, 5, so we have 20 times 13, or 260 units squared is going to be the lateral area. Okay, now let's find the total area. Well, remember, total area is lateral area plus the base area. So lateral area is 260 plus the base area is 10 times 10. So total area is 360 units squared. And now let's find the volume. So remember that the volume is 1/3 the base area times the height. And this is the height of the pyramid, so it's 1/3 base area, which was 100, times the height, which is 12. So 3 goes into 12 4 times, so this is 400 units cubed. So the volume is 400 units